Okay, so next type of motion in uniform electric field, what does it do is we have a charge, okay, and then there are two parallel plates like this, and one of the parallel plates is positively charged and the another parallel plate is negatively charged. The electric field here inside in this region hingirutte from positive to negative, yes, so it will be uniform like this from positive to negative. Yes, that is in the downward direction. Let's say there is no other force, not even gravitational force is also there. Now, ಇದೊಂದು charge uniform velocity ಇಂದ travel ಮಾಡ್ತಾ ಇದೆ in a straight line. As soon as it enters this electric field, what will it experience? It will experience an electric force. Our direction ಏನಾಗುತ್ತೆ? That direction is in the downward direction. Okay. So instead of going straight, as soon as it enters this electric field, what will it experience? It will experience a downward force. As it experiences downward force, what happens is this trajectory will change like this. Yes, this trajectory will change like this. Okay. Ade, instead of a positive charge, if you have a negative charge, right? Instead of a positive charge, if you have a negative charge, what do you think will be the trajectory of that? Negative charge it is going with the uniform velocity u towards right, and it enters this electric field. In negative charge ಮೇಲೆ force ಯಾವ direction ಬರುತ್ತೆ as soon as it enters in this electric field ಯಾವ direction ಇದೆ downward. Negative charge ಮೇಲೆ electric force ಏನಾಗುತ್ತೆ opposite to field. Okay, positive ಮೇಲೆ downward ಇದ್ರೆ negative ಮೇಲೆ ಏನಾಗುತ್ತೆ negative ಮೇಲೆ. So what will be the trajectory of this? The trajectory of this will be now both of these, yes, both of these will be what? Both of these will be parabolic paths, yes or no? Both of these will be parabolic path, yes or no? Parabolic path ಗೊತ್ತಾಗುತ್ತೆ. Path taken by any particle. How do you understand path taken by any particle? If you have this, okay, if you know what is the relation between force and velocity, if you know what is the relation between force and velocity, you will understand what is the path that the object takes. Okay, so let's say the velocity of the object is towards right and the force is also in the same direction. Okay, what force am I talking about? I am talking about the net force. Okay, then ಏನಾಗುತ್ತೆ to this, it will keep on continuing in the same direction, but ಏನಾಗುತ್ತೆ velocity magnitude increase ಆಗ್ತಾ ಹೋಗುತ್ತೆ. So the direction will be that it will travel in a straight line, but its velocity will keep on increasing. Yes. So that is if force and velocity have this relation. Again, if the force and velocity have opposite relation, that is velocity e direction is there, force is in this direction, what will happen? Or we will reverse this. Okay, yeah, this is also fine. The force is towards left and velocity is towards left, the force is towards right. In the opposite direction with the ಏನಾಗುತ್ತೆ? Because of this force, the velocity ಕಡಿಮೆ ಆಗ್ತಾ ಹೋಗುತ್ತೆ, but it does not mean that immediately it will go towards right. Okay, ಯಾವ ಡೈರೆಕ್ಷನ್ ಅಲ್ಲಿ ಮೂವ್ ಆಗುತ್ತೆ ಅದು ಎದರ ಮೇಲೆ ಡಿಪೆಂಡ್ ಆಗುತ್ತೆ ಅಂದ್ರೆ ಅದು ವೆಲಾಸಿಟಿ ಮೇಲೆ ಡಿಪೆಂಡ್ ಆಗುತ್ತೆ. In this case the velocity is towards left. What will it do? It will move towards. What does force tell us? Velocity ಈ instant in the next instant ಹೆಂಗೆ ಚೇಂಜ್ ಆಗುತ್ತೆ ಅನ್ನೋದು ಫೋರ್ಸ್ ಹೇಳುತ್ತೆ. Okay, ಈ ಇನ್ಸ್ಟೆಂಟ್ ಅಲ್ಲಿ ಜಾಸ್ತಿ ಇದ್ರೆ ನೆಕ್ಸ್ಟ್ ಇನ್ಸ್ಟೆಂಟ್ ಅಲ್ಲಿ ಕಡಿಮೆ ಆಗುತ್ತೆ, ಯಾಕಂದ್ರೆ ಫೋರ್ಸ್ ಇಸ್ ಆಪೋಸಿಟ್ ಟು ವೆಲಾಸಿಟಿ. ಸೊ ವಾಟ್ ಇಸ್ ದ ಪಾತ್ ದಿಸ್ ವಿಲ್ ಟೇಕ್? ದಿಸ್ ವಿಲ್ ಗೋ ಸ್ಟ್ರೇಟ್ ಅಂಡ್ ಕಮ್ ಬ್ಯಾಕ್ ಲೈಕ್ ದಿಸ್. It will go straight and back like this. Yes sir. Yes. Ade, if there is any other relation between force and velocity, if there is any other relation between force and velocity, let's say velocity is like this, and this force is what? This force is ಯಾವ ಪಾತ್ ತಗೊಳುತ್ತೆ? ಫೋರ್ಸ್ ಕಾನ್ಸ್ಟೆಂಟ್ ಆಗಿದೆ ಅಂಡ್ ವೆಲಾಸಿಟಿ ಅಂಡ್ ಫೋರ್ಸ್ ಅಲ್ಲಿ ಯಾವುದೋ ಒಂದು ಬೇರೆ ಆಂಗಲ್ ಇದೆ. ದಿಸ್ ಆಂಗಲ್ ಇಸ್ ನೈದರ್ 0 nor 180. ಈ ಆಂಗಲ್ ಇದ್ದಾಗ ಏನಾಗುತ್ತೆ? ಇವಾಗ ಮಾತಾಡಿದ್ರೆ projectile motion ಏನಿರುತ್ತೆ force of gravity downward direction and the velocity is making some angle with the force. ಈ ತರ ಫೋರ್ಸ್ ಅಂಡ್ ವೆಲಾಸಿಟಿ ಅಲ್ಲಿ ಏನಾದರೂ ಒಂದು ಆಂಗಲ್ ಇದ್ರೆ ಯಾವ ಪಾತ್ ತಗೊಳ್ಳೋದಂದ್ರೆ ಇಟ್ ವಿಲ್ ಟೇಕ್ ಅ ಪ್ಯಾರಾಬೋಲಿಕ್ ಪಾತ್. ಇಟ್ ವಿಲ್ ಟೇಕ್ ಅ ಪ್ಯಾರಾಬೋಲಿಕ್ ಪಾತಿಗೆ ಏನಪ್ಪ ಈ ಫೋರ್ಸ್ ಕಾನ್ಸ್ಟೆಂಟ್ ಇರಬೇಕು. ಏನಿರಬೇಕು? ಫೋರ್ಸ್ ಕಾನ್ಸ್ಟೆಂಟ್ ಇರಬೇಕು. ಸೊ ಲುಕ್ ಅಟ್ ದಿಸ್, the charge is constant, the electric field throughout this region is constant, which means can I say that electric force which will be equal to Q into E, it will be constant. This since it is constant, what is the angle between velocity and force? The angle between velocity and force is what? 90 degree. So ಯಾವ path ತಗೊಳುತ್ತೆ ಅದು? Both of them will take parabolic path. Both of them will take parabolic path. ಯಾವುದೇ angle ಇರಲಿ, no matter what angle it is, okay, even if it is 90 degree, okay, or anything, if except for 0 and 180. 0 and 180 ಅಲ್ಲಿ ಏನಾಗುತ್ತೆ? 0 ಇದ್ದಾಗ ಸೇಮ್ ಡೈರೆಕ್ಷನ್ ಅಲ್ಲಿ ಕಂಟಿನ್ಯೂ ಆಗುತ್ತೆ, 180 ಇದ್ದಾಗ ಹೋಗ್ಬಿಟ್ಟು ವಾಪಸ್ ಬರುತ್ತೆ. and all these three I am talking about constant force. okay, variable force ಇಂದ ಮತ್ತೆ ಚೇಂಜ್ ಆಗುತ್ತೆ. now there is one more case here, is if the velocity and the force are always perpendicular. If the velocity and the force are always perpendicular, ಅವಾಗ ಯಾವ ತರ ಬಿಹೇವ್ ಮಾಡುತ್ತೆ? ಯಾವಾಗಲೂ ಪರ್ಪೆಂಡಿಕ್ಯುಲರ್ ಇರುತ್ತೆ. ಸರ್ಕ್ಯುಲರ್ ಮೋಷನ್ ಯಾವ ತರ? ಎಸ್, what kind of motion? Circular motion. Circular motion ಏನಿರುತ್ತೆ? Force is towards the center and the velocity is towards the end, right? In this case what happens is the force is always perpendicular to velocity. But is this a constant force? No, constant force ಅಲ್ಲ. ಯಾಕಂದ್ರೆ ಇಲ್ಲಿದ್ದಾಗ ಫೋರ್ಸ್ ಡೈರೆಕ್ಷನ್ ಇದು ಇದೆ, ಇಲ್ಲಿ ಬಂದಾಗ ಫೋರ್ಸ್ ಡೈರೆಕ್ಷನ್ ಇದು, ಇಲ್ಲಿದ್ದಾಗ ಫೋರ್ಸ್ ಡೈರೆಕ್ಷನ್. So direction of the force, as you can see, it is continuously changing. So is it a constant force? So parabolic path ಯಾವಾಗಿರುತ್ತೆ ಅಂದ್ರೆ, parabolic path ಯಾವಾಗಿರುತ್ತೆ when the force is constant. The forces, as you see here, ಇಲ್ಲಿಂದ ಇಲ್ಲಿಗೆ ಈ ಚಾರ್ಜ್ ಟ್ರಾವೆಲ್ ಮಾಡ್ತಾ ಇರುವಾಗ the electric force is constant. Since the electric force is constant, what happens is it will take a parabolic path, whether it is a positive charge or whether it is a negative charge. So positive charge ಇದ್ದಾಗ it will deviate towards negative plate. Negative charge idaga it will deviate towards positive plate. Okay, you can simply think of it as negative charge being attracted towards positive plate and positive charge being attracted towards negative plate. So it's a positive charge, deviate down. If it's a negative charge, it will deviate up. Okay. Okay. Now, one of the general things that they ask is enter ಆಗೋದು horizontal enter ಆಗ್ತಾ ಇದೆ, exit ಆಗೋದು ಈ ತರ exit ಆಗ್ತಾ ಇದೆ. So So what is the angle at which it exits? Right? What is the angle at which it exits? Length ಕೊಡ್ತಾರೆ L. Let's say the electric field here. Okay, so in this case it will go up, not down. Let's say it is exiting here. Now, for angle of exit in Madhira, what do you calculate? You simply use this, that is tan theta is equal to Vy divided by dx. Tan theta is simply equal to Vy divided by dx, very similar to projectile motion. Yes. Okay. Now, electric field, vertical direction. So each charge particle, when it is inside, it is only experiencing vertical force. It is only experiencing vertical force. Horizontal directionally, there is no force. So horizontal component of velocity will remain same, yes or no? Horizontal component of velocity will remain same. Horizontal directionally, there is no external force. There is only external force in the vertical direction. Okay. So what is the net force acting on the charge? The net force acting on the charge is simply Q into E, and in which direction it is acting? It is acting along Y direction. Okay. Similar to projectile motion, since there is no force along x direction, what do we write? We write initial velocity when it is entering the horizontal direction is equal to final velocity while exiting. Yes? Adano, x axis along x axis. So you write ux is equal to dx. Okay. Now it is entering the electric field on this end and it is exiting the electric field on this end. So what is the horizontal displacement that it is covering? The horizontal displacement that is covering is this length L. Yes or no? Okay. Now how much time it is taking to exit? How do you calculate? Time taken to exit. Time taken to exit simply equal to this displacement divided by velocity. Yes or no? It is entering at this point, okay, and it is exiting at this point. What is the horizontal displacement? Horizontal displacement is here. What is the horizontal velocity? Horizontal velocity you are taking it as u. Since there is no force along horizontal direction, time taken will be simply displacement divided by velocity. Okay, how much is this? Sx is L. Okay, divided by ux is simply. Okay. So time yaak ಬೇಕಾಗಿತ್ತು ನಮಗೆ. Time yaak ಬೇಕಾಗಿತ್ತು. Why did we calculate time? Because what do we have here? For angle of exit, tan theta, we need Vy divided by Vx. Vx we already know that is equal to u. But Vy ಹೆಂಗೆ calculate ಮಾಡ್ತೀರಾ? Okay. So Vy square is equal to Uy square plus 2 Ay into Sy. Either you use this or what do we use? Vy is equal to Uy plus Ay into T. Now since we do not know what is the displacement along vertical direction, we will not be using this. Instead we will be using this V is equal to U plus AT. Okay, because we know the time. Time ಏನು ಇಲ್ಲಿಂದ ಇಲ್ಲಿಗೆ ಎಕ್ಸಿಟ್ ಆಗೋ ತನಕ ಅದೇನಾಗ್ತಾ ಇದೆ ಮೇಲೆ ಹೋಗ್ತಾ ಇದೆ ಸರ್. ಇಲ್ಲಿಂದ ಇಲ್ಲಿಗೆ ಎಕ್ಸಿಟ್ ಆಗೋ ತನಕ ಅದು ಮೇಲೆ ಹೋಗ್ತಾ ಇದೆ. As soon as it comes out it just goes straight again because there is no force on that. Okay. Because inside here electric force is there, what is doing is it is going like this, deviating. As soon as it exits, what does it do? We are not worried about what happens after the exit. We are just worried about as soon as it exits, what is the angle it is making. So what we will use is, we will use this. So Vy, what is the velocity along vertical direction initially? 0. The horizontal enter ಆಗ್ತಾ ಇದೆ ಅಂದ್ರೆ vertical direction initial velocity is 0. Plus what is the acceleration along y axis? QE divided by m. Just simply Q into E divided by m. And what is the time taken? L by U. The time taken is L divided by U. So therefore Vy in barta ideppa, Vy you are getting it as how much? QEL divided by m into QEL divided by m. So now you find tan theta is equal to Vy divided by Vx, which will be equal to QEL divided by m into U square. QEL divided by m into okay. So you can write down all the things in this. Yes. Velocity along vertical direction during exit ಎಷ್ಟು ಬರ್ತಾ ಇದೆ? It is coming out to be QEL divided by m into U. Okay. Then angle of exit tan theta is coming out to be yes QEL divided by m into U square. Can you also tell me what will be displacement along y axis before it exits? Calculate ಮಾಡಿದ್ರೆ simply uyt plus half ay into t square. So uyt is 0, half ay into t square. Ay is how much? Ay is qe divided by m. Qe by m into t square. T square is l square divided by q square. ಎಷ್ಟು ಬರ್ತಾ ಇದೆ ಮಾಡಿದ್ರೆ half qe by m l square by u square. This is coming out to be qe l square divided by okay. Everything in motion problems can be once again repeated here. The only thing that is added from there is here you will have an extra force called as electrostatic force. Electrostatic force ಹೆಂಗಿರುತ್ತೆ ಅದು ಫೋರ್ಸ್ ಡೈರೆಕ್ಷನ್ ಏನಿರುತ್ತೆ ಅಂತ ಹೇಳ್ಬಿಟ್ಟು ಇಲ್ಲಿ ತನಕ ಕಲ್ತಿದೆ ಅದಾ Finish? Yes? Okay. See. Now, what happens if you place a dipole in a uniform electric field? So, dipole consists of both plus q and minus q. Yes or no? Dipole consists of both plus q and minus q. So, let's say this is the uniform electric field. In short, these are the two formulas that are important here. One is torque, the other one is work done. Okay. Now we will understand what it is. If we have, let's say, dipole hengirutte one minus, and then attached to that there will be plus. Okay, so this is minus q and this is plus q. Okay? And the electric field is uniform. Electric field is uniform andre. Now, because of this uniform electric field, this minus q will experience a force. Yes, what will be that force? What will be that force? That force will be opposite to electric field, and that will be how much? That will be q into E. Yes or no? That will be q into E. What about the plus q? Plus q will also experience a force. What will be the direction? In the direction of electric field, and how much will be that? Q into E. Now if you write net force on the dipole, if you write net force on the dipole, ಏನಾಗುತ್ತೆ? It will be force on plus q plus force on minus q. Yes sir. Because dipole consists of what? Dipole consists of minus q and plus q. So minus q mele plus q mele. So what will be the net force? Net force will be qe minus qe. So net force on dipole in barta ide. Net force on dipole. Yes, it's coming out to be 0. Net force on dipole is coming out to be 0. ಯಾಕಂದ್ರೆ ನೆಗೆಟಿವ್ ಮೇಲೆ towards left idre, positive ಮೇಲೆ towards right. Because of this left and right, the net force on this will become 0. So what happens when you place an electric field, in a dipole in a uniform electric field andre adar mele net force enirutte, net force will be 0. But because this is like a rigid object like this, okay, a rigid object mele ಮೇಲ್ಗಡೆ ನಾನು towards right, ತೆಳಗಡೆ towards left force apply ಮಾಡಿದ್ರೆ ಏನಾಗುತ್ತೆ ಅದು? Simply take a pen and apply force. the opposite direction, what will happen? A rotating effect is created. Yes, a rotating effect is created and you will get a torque. That torque, equal and opposite force at distance L, what do you get? You get a couple. Yes, you get a couple. What is the torque due to a couple? What is the torque due to a couple? Force into perpendicular distance. Yes or no? Force into perpendicular. Do you understand? They are forming couple. Couple andre ಏನು? Torque ಅಲ್ಲಿ couple andre ಏನು? Torque ಅಲ್ಲಿ couple andre ಏನು ಅಂದ್ರೆ you have ಎರಡು equal force opposite direction ಅಲ್ಲಿ. ಇದರಿಂದ ಏನಾಗುತ್ತೆ? Net force is 0, whereas net torque is actually not equal to 0. ಇದು ಯಾವ ತರ equilibrium ಇದೆ? Net force ಅಂದ್ರೆ ಯಾವ equilibrium? It is what? It is called as translational equilibrium. ಅದೇ net torque is 0 ಅಂದ್ರೆ ಏನಾಗುತ್ತೆ ಅದು? Rotational equilibrium. ಎರಡು 0 ಇದ್ದಾಗ ಎರಡು equilibrium ಇದೆ. ಒಂದು 0 ಇದೆ, ಒಂದು equilibrium ಇದೆ, ಇನ್ನೊಂದು equilibrium ಅಲ್ಲಿ ಇಲ್ಲ ಅಂತ ಹೇಳ್ತೀವಿ. Yes. So couple is what? Couple is if you have two equal forces acting opposite direction. So what do you get? You get simply a torque. You get a simply torque. So torque na yav thara calculate ಮಾಡ್ತಾರೆ? If you have this force, this F, if you have this force F, ಎರಡರ ನಡುವೆ perpendicular distance L ಅಂತ ಇದ್ರೆ simply torque is equal to F into in this case, so let's say this length is 2a. Let's say this length is 2a. So what will be the perpendicular distance between the two forces? ಹೆಂಗ್ ಮಾಡ್ತೀರಾ ಅಂದ್ರೆ dipole ಹೆಂಗಿದೆ? This is the direction of dipole. Yes sir. From minus to plus, this is the direction of dipole. I will take this angle as theta. So what will be perpendicular distance? Perpendicular distance is the perpendicular distance is this, yes or no? Now look at this right angle triangle. This angle is theta. So this will be and what is this? This is the perpendicular distance between this force and this force. Therefore torque will be equal to how much? F into perpendicular distance. What is F? F is Q into E. What is the perpendicular distance? The perpendicular distance is 2a into sin theta. Okay. Now this torque can be written as E into Q into 2a into what is Q into 2a? What is Q into 2a? P. Q into 2a is nothing but P. Therefore, what do you get is you get torque will be equal to so not here. Yes. In ಡೈಪೋಲ್ ನಾವು ಯೂನಿಫಾರ್ಮ್ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಇಟ್ಟರೆ ಅಲ್ಲಿ ಇಟ್ಟರೆ ಏನಾಗುತ್ತೆ, it will experience net torque whereas it will not experience net force. Okay, net force ಅದರ ಮೇಲೆ 0 ಇರುತ್ತೆ, whereas net torque will be simply equal to P cross E. Net torque will be simply equal to P cross okay. So dipole in a uniform electric field, this is extremely important, okay, with respect to your boards as well. Okay. Now we will write this manner. ಒಂದು ಡೈಪೋಲ್ನ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡಲ್ಲಿ ಇಟ್ಟರೆ ಏನಾಗುತ್ತೆ ಅಂದರೆ, ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಏನು ಮಾಡುತ್ತೆ, ಆ ಡೈಪೋಲ್ನ ಅದರ್ ಡೈರೆಕ್ಷನಲ್ಲಿ ರೊಟೇಟ್ ಮಾಡೋದಕ್ಕೆ ಟ್ರೈ ಮಾಡುತ್ತೆ. ಓಕೆ, ಇಫ್ ಯು ಹ್ಯಾವ್ ದಿಸ್ ಪ್ಲಸ್ ಆ್ಯಂಡ್ ಮೈನಸ್, ವಾಟ್ ಇಸ್ ದ ಫೋರ್ಸ್ ಆಕ್ಟಿಂಗ್ ಟುವರ್ಡ್ಸ್ ರೈಟ್ ಆ್ಯಂಡ್ ಟುವರ್ಡ್ಸ್ ಲೆಫ್ಟ್? ಎಸ್. ಸೊ ವಾಟ್ ಇಸ್ ದ ರೊಟೇಷನಲ್ ಎಫೆಕ್ಟ್? ಕ್ಲಾಕ್ ವೈಸ್, ಆಂಟಿ ಕ್ಲಾಕ್ ವೈಸ್? ಕ್ಲಾಕ್ ವೈಸ್. ಸೊ ಕ್ಲಾಕ್ ವೈಸ್ ಏನು ಡೈರೆಕ್ಷನ್ ಇದೆ? ಕ್ಲಾಕ್ ವೈಸ್. ಇಟ್ ಇಸ್ ದ ಡೈರೆಕ್ಷನ್ ಆಫ್ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್. Okay, so simple ಆಗಿ ಅರ್ಥ ಮಾಡ್ಕೋಬೇಕು ಅಂದ್ರೆ, if you have a dipole which is placed in uniform electric field ಏನು ಮಾಡುತ್ತೆ? ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಆ ಡೈಪೋಲ್ ನ ಅದರ ಡೈರೆಕ್ಷನ್ ಅಲ್ಲಿ ರೊಟೇಟ್ ಮಾಡೋದಕ್ಕೆ ಟ್ರೈ ಮಾಡುತ್ತೆ. How will it rotate? To rotate, it will apply torque. Now, how do you calculate that torque? That torque is simply P cross E. So we can write an electric field electric field direction ಅಲ್ಲಿ ಡೈಪೋಲ್ ನ ರೊಟೇಟ್ ಮಾಡೋದಕ್ಕೆ ಟ್ರೈ ಮಾಡುತ್ತೆ. Okay, so if I ask you, this is the electric field and this is the dipole. Okay, in which direction the dipole will try to rotate? Clockwise or anti-clockwise? Anti-clockwise ಅಂದ್ರೆ ಟಾರ್ಕ್ ಯಾವ ಡೈರೆಕ್ಷನ್ ಇರುತ್ತೆ? Torque will be the outward direction. P cross E, it is out. It will make it try to rotate in this direction. So when the dipole is rotating, dipole moment change ಆಗ್ತಾ ಇದೆಯಾ? P is what? P is Q into 2A. That is not changing. Yes. Electric field E, we have already taken that, it is uniform. Yes. So rotate ಆಗುವಾಗ P change ಆಗ್ತಾ ಇಲ್ಲ, E change ಆಗ್ತಾ ಇಲ್ಲ, but ಏನು change ಆಗ್ತಾ ಇದೆ? Yes. So torque change ಆಗುತ್ತಾ? As it changes, torque also changes, or as it rotates, torque also changes. Why? Not because E is changing, not because P is changing, it is because theta is changing. So is this a constant torque? No, this is a variable torque. It is a variable torque. So variable torque ಇದ್ದಾಗ how do you calculate work done? Now you know how to calculate work done due to force. How do you calculate work done due to force? It is F dot S. It is simply force into displacement, linear displacement into But if the force is variable, ಏನು ಮಾಡ್ತಾರೆ, F is integral F dot, sorry, W is equal to integral F dot ds. ಅದೇ ವರ್ಕ್ ಡ್ಯೂ ಟು ಟಾರ್ಕ್ ಹೆಂಗೆ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡ್ತೀರಾ? Force is replaced by rotational effect of force, which is torque, and linear displacement is replaced by angular displacement. ಅದೇ ಟಾರ್ಕ್ ವೇರಿಯಬಲ್ ಇದ್ದಾಗ ಏನು ಮಾಡ್ತೀರಾ? ಟಾರ್ಕ್ ವೇರಿಯಬಲ್ ಇದ್ದಾಗ if you want to calculate work done because of torque, it is simply integration of tau d theta. It is taken as integration of tau d theta. Okay. Now, what is the torque on a dipole? The torque on a dipole is Pe sin theta d theta. Let's say you are rotating. Let's say you are rotating this from angle theta 1 to angle theta 2. The theta 1 angle in the theta 2 angle rotate ಮಾಡ್ತಾ ಇದ್ದೀರಾ. So the only variable in this integration is what? The only variable in this integration is theta. So angle theta 1 to theta 2. If you integrate, what you will get Pe minus cos theta, theta 1 to theta 2. ಯಾಕಂದ್ರೆ integration of sin theta is what? Integration of sin theta is minus cos theta. Integration of sin theta is minus cos theta. Minus cos theta ಅಲ್ಲಿ if you substitute this, what you will get Pe cos theta 1 minus cos theta 2. So what is this? So this is work done. We get theta 1 minus, so work done is equal to cos Okay, do you understand why we did integration? Yes, because torque is not constant. Okay. Okay. Now, if dipole and the electric field is there in the same direction, this position is called as what? Stable equilibrium position. This position is called as stable equilibrium position. Okay. And if dipole and the electric field are in the opposite direction, this is called as unstable equilibrium position. Yeah, okay. Here, what is the angle between P and E? 0 degree. So torque is 0. Already force 0. E position li torque no 0. So adikke idana equilibrium anta karithivi. Now if P and E are opposite to each other, what is the angle? 180. What is sine of 180? 0. So E position ಅಲ್ಲಿ ಇದ್ದಾಗ ಕೂಡ ಏನಾಗುತ್ತೆ? Torque is 0. E position ಅಲ್ಲಿ torque 0. If you rotate it, what will the electric field try to do? It will try to bring it back in the direction of electric field. ಅದೇ ಇಲ್ಲಿ rotate ಮಾಡಿದ್ರೆ ಸ್ವಲ್ಪ it will go in the opposite direction to the displacement. Okay. Sure.